Hi everyone, today we're going to look at what it means to solve a right angle triangle. Solving a right angle triangle really just means to determine all the angles and all of the side lengths of the triangle. You're going to need some various tools to be able to do this. The primary trig ratios will be one set of the tools. We'll remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent. Don't forget that you can use SOHCAHTOA to help you to remember these primary trig ratios. The other tool that you'll have in your toolbox is the Pythagorean theorem, the a squared plus b squared equals c squared. We've also thought about this in the past as being leg squared plus leg squared equals c squared in order to find a hypotenuse. Or we can use leg squared equals hypotenuse squared minus leg squared to find the length of a missing leg. The final tool in your toolbox that you're going to need is the interior angle sum. This is the theory that tells us that if we add all of the angles inside of a triangle that we should get 180 degrees. We'll note that in right angle triangles, we'll always know one of the angles is 90 degrees, so this will be helpful to us. To begin to solve a triangle, we'll need to look at what we've been given. In this example, we've been given an angle, or a theta, of 45. That'll be our reference angle. We've also been given an adjacent value of 10 meters. Remember that across from your theta is your opposite value, and across from the right angle is your hypotenuse value. The remaining value is your adjacent side. So in this case, we have an adjacent and we have a theta. We're going to need to figure out which trig ratio we should use to find one of the other side lengths. It makes sense that we would use something that includes the adjacent value since we have it, and depending on which value we want to find next, we could either choose cosine or we could choose TOA or tangent. In this case, let's pick tangent. We know that the tan of theta is equal to the opposite over the adjacent. Tan of 45 is equal to a over 10. From there, we'll need to find out what the tangent of 45 is. So we'll type in 45 and hit the tangent button on our calculator, and we'll get 1. So we'll have 1 is equal to a over 10. This almost looks like a proportion. We'll need to put a 1 underneath the other one, and then we'll be able to cross multiply. So we'll have 1 times a is equal to 1 times 10, or a is equal to 10. That was easy. We've now found that the value of the opposite side is 10 meters. So we can add that to our diagram. We'll add this label to our diagram because it will help us in finding the next value that we need. Let's go to find b as our next value, or the hypotenuse. Now we have some choices. We could go back and use one of the primary trig ratios that has a hypotenuse within it, or we might recognize that we now have two leg values of this right angle triangle, so we can use the Pythagorean theorem. We'll have the hypotenuse squared equals leg squared plus leg squared, or b squared equals 10 squared plus 10 squared. This means b squared is equal to 100 plus 100, or b squared is equal to 200. If we take the square root of 200, we will get that b has a value of approximately 14.14 meters. We'll add this to our diagram as well on our way to solving the entire triangle. Remembering that to solve a triangle means we'll have all the side lengths, which we do, as well as all the angle measurements. We're missing the angle measurement c here, but we can use our interior sum rule for the triangles to figure it out. We know that 45 plus 90 plus angle c will have to be equal to 180 degrees. So we can add the 45 and the 90 together to get 135. We can move that across the equal sign to the 180, which will mean 180 minus 135 is equal to angle C. This means that angle C is equal to 45. So now we have all the angle measurements and all the side lengths of this triangle, so we can consider this triangle solved. In the triangle of our second example, we're given two side lengths and the 90-degree angle. Notice that we're missing the two other angles inside the triangle, and we're missing one of the legs. We can use the Pythagorean theorem to find out that remaining side length of the leg. We'll do this by using leg squared equals height squared minus leg squared. We can substitute the values we know into this to be leg squared equals 30 squared minus 10 squared. We can continue with leg squared equals 900 minus 100, or leg squared, equals 800. When we take the square root of 800, we will find that the leg is approximately equal to 28.28 feet. We'll label this on our triangle, and then we will try to figure out how we can find one of those missing angle measurements. Let's put a theta at angle x and use it to try to see if which trig ratio will apply. If we use theta as our reference angle, then we know the opposite value of 10 feet and we know the hypotenuse value of 30 feet. Because we have the opposite and the hypotenuse, we can use the sine ratio. So sine of theta will be equal to opposite over hypotenuse. This means that the sine of theta is equal to 10 over 30. As we divide out 10 by 30, we'll get 0.3 repeated. So to find what theta is, we'll need to use the inverse of sine. So theta will be equal to the inverse of sine of 0.3 repeated. We can use our calculator to find this by typing in 0.3 repeated to our calculator and then hitting the second function button and the inverse sine button, which will give us that theta is approximately equal to 19.47 degrees. We'll label this in our triangle at angle x, and then from there we can use the interior sum of the triangles to find the missing angle measurement at angle y. We know that 180 will be equal to 19.47 plus 90 plus angle y. If we add together the 19.47 and the 90, we'll get 109.47. We'll subtract this from 180, and that will give us a y value of 70.53 degrees. So we'll label this in our triangle, and we can look at it and see that we have all of the angles inside the triangle, and we have all of the side measurements of the triangle as well. So again, we can consider this triangle as solved. Once again, solving a triangle means you need to find all the side lengths and all the angle measurements. The order and method that you use to do this will depend on which tools you want to use out of your toolbox and in what order. That may vary from question to question and from person to person, but you should all find the same side lengths and the same angle measurements no matter which tools you choose to use.